Okay, we are joined by my old friend and colleague, Derek Churchill. And tonight I'm really excited to have him joining us because this represents a real tipping point in our class. We've spent the past few weeks taking a look at the formative processes that have shaped the landscape of the Northwest with uh, uh, Paul Butler's presentation on geology and soils. I had Jessica Lofsky join us and talk about historic climate and present climate and where we see things going in the future and the relationship between climate and forests, and in particular impacts to future forests. And then you've been doing a lot of reading about forest ecology, learning about the forest developmental processes, natural disturbance regimes, all those kind of natural factors that lead to the forest composition and structure that we have. And so now, with that understanding of the inherent ecological processes behind forest development, we're going to begin a conversation of how to translate those ecological processes into principles of active forest management. And that's largely what I've asked Derek Churchill to do, and really begin defining the elements of applied ecological forestry. So I've been working with Derek for, gosh, I don't know, 10, 15 years or so. And he has taught a lot of workshops through my organization on ecological forest management, and has had a really interesting arc to his career from being a teacher of forestry at the University of Washington and working closely with Jerry Franklin, to having a private consulting business, and now having the distinction of working for our State Department of Natural Resources at a landscape level, and having some significant influence on how both state lands are managed and how our State Department of Natural Resources resources can be used to help private landowners improve their forests and the resilience of those forests in the face of climate change. So with that as a introduction, Derek, I'd like to turn it over to you, and I'm going to give you co-host power here, hopefully. I can remember how to do that. There we go. And yeah, if you wouldn't mind providing some of your own introduction and then take it from there.
Sure. Yeah, it's great to be here this evening. Just I haven't been on Zoom at night for a little while, so adjusting the lights and whatnot. Yeah, as Kirk said, we've worked together for quite a while now. I kind of came into forestry sort of in my early to mid 30s. Before that, I ran youth programs and worked for Outward Bound and sort of had a whole nother career. And so went back to get a master's or start forestry at UW and kind of the early 2000s. And so anyway, it's great to meet you all. As Kirk said, one of my roles, I worked at UW, got my doctorate there, and then taught a number of classes, including a sort of applied forest management class where we developed a management plan for a King County property, forest property. And so the whole class is oriented around teaching the students the skills to write a management plan and then actually writing the plan, and then we present it to the county and whatnot. And a number of those plans have actually been put into place, and they've done various treatments from the plans or whatnot. So I've really enjoyed working with students over the years. So yeah, it's great to be here. Let me see here. Okay. Email. Oh, it's over here, sorry. Okay. Okay. Yeah, how many of you can get more of you guys on there? So, sorry, I gotta jump that back. Okay, here we go. The usual Zoom thing here. My talk tonight, I'll talk a little bit about what I do at DNR, their experience, but I'm going to focus on kind of a little more of the nuts and bolts of applied forest ecology. One of the official definitions or long time definitions of silviculture, and I think to me that's really the way I like to think about silviculture is applying our knowledge of forest ecology to forests for a variety of different objectives, whether those be ecological or social or cultural or economic, or usually some combination thereof. And again, coming back to the students thing, there's a lot of really interesting career paths in forestry. And it said I kind of started mid-career, and have had a lot of students go on to do all kinds of things, from working for the Forest Service, being a lands forester, doing lots of actual nuts and bolts, prescription writing and sort of on the ground forestry, to working for conservation organizations, whether those be land trusts or environmental groups, working for counties and state government, working for consulting businesses. There's really a lot of, for a while, forest industry was there was fewer and fewer jobs, but really over the last, I'd say 10 or 15 years, there's a lot of kind of the old, when forestry really expanded in the 60s, a lot of those are retiring. And so there's really a lot of openings, particularly for people that are willing to move to rural communities or whatnot. That's one of the challenges. A lot of the forests aren't next to cities, but there's also lots of jobs in cities too. Anyway, I don't know what your guys' plans are career-wise or whatnot, whether forestry is part of it, but we've just had a lot of students end up in interesting jobs over the years. And I've certainly done a lot of different types of aspects of forestry. When I started, I moved to Vashon Island and bought some forest land, and took a stewardship planning course with the county and the DNR, and that was my first introduction to forest ecology. And I realized, hey, my own land is this mature alder forest. I should probably do some planting, and I did kind of a small harvest, and I actually did most of the harvest myself. There's me, I rented a little bit, did skid steer and did all the yarding and whatnot. And from that experience, I learned that I really didn't want to be a logger, that it's like really hard work and things are breaking down and it was stressful and all this kind of stuff. But I also gained a lot of respect for that side of forestry as well, because it is really hard and challenging. And then I was a consulting forester for a long time, working with private landowners, counties, land trusts. A lot of my clients, my sort of niche was really ecological forestry. People that were managing for, again, an array of objectives, sometimes including economic, sometimes not, but really interesting challenges. Forestry's, it's a lot simpler and easier when you're just managing for one thing. Like if you're trying to maximize revenue or just manage for old growth, it's more clear cut. But when you're managing for recreation and for a little bit of income and for habitat, and you have all these people that really care about this park or this forest or this public land that you're managing, and people who may be pissed off at what you're proposing or scared, nervous, or that the public side of forestry or social side of forestry is really interesting and engaging. And some people are kind of scared about it, and they're like, I just want to drive out in the woods and do my job and not have to deal with people. But for me anyway, I really enjoy that side of it, that you just have to use those people skills, really be willing to listen, to be humble. And for a long time in forestry, there's sort of this ethos of, you go to school, you get this technical training that teaches you how to manage forests, and you're now the expert. And so you know how to manage the forest, and hey, the public, they don't really know much about forests. So yeah, they may have some comments, but you really know, you're the forester, you know how to manage the forest. You don't really need to listen to them. And that whole approach, particularly for public lands forestry, really got public agencies into a lot of trouble, and it just doesn't work. In reality, all kinds of people have knowledge and experience about forests, and you may have some technical knowledge or ecological knowledge or scientific knowledge, but there's a lot of other kinds of knowledge that's really important. And so being humble, being willing to listen and engage with people, and I often realized that I learned a ton from that, and met a lot of different people. So that's one other thing I'll say here is that in this really polarized country that we live in, forestry is a profession where you get people from a lot of different backgrounds, a lot of people from rural communities, a lot of blue collar folks, a lot of sort of professionals, a lot of researchers, academics, a lot of community folks from all kinds of places, recreationists. And so you get these situations, whether they're around managing a particular piece of land or whether they're working on a collaborative group on a national forest, where you get people from different backgrounds with sometimes really opposing and conflicting views, environmentalists and folks from timber industry and unions and all kinds of things. And you realize that when people actually are part of a group that has to find a solution or figure out a way forward, people can actually get along. And so in this day and age, forestry's given my work in forestry gives me a lot of hope that we aren't just completely polarized in this country. So I am going to get to the forestry part here, but to me, the social side is just as interesting. So anyway, as I mentioned, I taught, I think 4 or 5 of these classes at University of Washington, which sounds somewhat similar to what you're doing. And then as Kirk mentioned, I also had a whole research kind of component at UW. But currently, I work for the Forest Health and Resiliency Division at the Washington State Department of Natural Resources. And this is a pretty new division. Until very recently, Forest Health was part of the Wildfire Division. And when most people think of DNR, they think of, oh, that's the agency that manages the state trust lands or the state forests. And those forests are managed primarily to produce revenue, to build schools, and as well also support county governments and universities and things like that. They also provide a lot of recreation and ecological benefits as well, but they have what's called the trust mandate. They need to produce revenue. But those are just state-owned lands. There's about 4 million acres in the state. But there's these other parts of DNR, the Wildfire Division, which basically puts out wildfires on primarily private land. And then the Forest Health, which tracks and does research and does education with a variety of landowners around, whether it's insect and disease, all kinds of things related to forest health. And for traditionally, people thought about forest health as, if your trees are dying, you call up an entomologist, and there's all kinds of reasons why trees die, and there's a problem, right? So we got to go out and figure out what it is and try to keep the trees from dying or try to figure out how to make the forest healthy again. Well, that definition of forest health has really expanded in recent years to now where we define forest health as the condition of a forest ecosystem with characteristic structure and function that's resilient to different disturbance agents, that can be adaptable to changing climate and drought stress, and the capacity to provide ecosystem services. So really this much broader definition of what a healthy forest is. And what's cool about our division is that we work across all lands, federal lands, private lands. We work with tribes, we work with other state agencies like Fish and Wildlife that owns a lot of land. And one of the main things that I work on is called this 20-year Forest Health Strategic Plan for Eastern Washington. As I'm sure many of you know, there's a lot of major forest health issues in Eastern Washington, from fire suppression and past logging and a variety of things. And so we have this really ambitious, big plan to work across all lands to try to get these forests in better shape, so we don't have, the huge destructive fires like they're having in California, or big droughts, or a lot of mortality from droughts or whatnot. We still need a lot of fire out there, but in this part of the world, but not fire that burns up, or kills so many trees. So that's what I currently do. I work with a whole team of scientists and planners who work with all these different stakeholders across the state. And then we have a lot of other specialists, again, that work on insect and disease, work with small landowner assistance, all kinds of things. So again, there's all kinds of interesting jobs out there that are related to forestry in different ways. So, okay, I'm gonna jump into silviculture right now. So, this is a very traditional definition of silviculture from Helms, which is, there's 4 or 5 kind of classic silviculture textbooks. And, for a long time, silviculture has been very focused on the wood production side of forest management. And so, the art and science of controlling the establishment, growth, and health of forests to meet the diverse need of landowners. And so again, as I'll talk about, that definition has definitely evolved. There's sort of, it's less clear exactly, what we're managing for these days. Silviculture has gotten more complicated in a variety of different ways, which ultimately is a good thing, I think. But I'm just gonna do a little introduction to kind of set up some sort of core fundamental concepts and principles of silviculture. First of all, that a silvicultural treatment is just a one-time management action. So when you go to do a thinning, or to do a planting, or to do invasive species control, that's not a silvicultural system. That's just a treatment. A silvicultural system is a whole process of managing forests, establishing forests, tending them over time, and potentially harvesting them at some point, whether it's most of the trees or some of the trees. In some cases, a system can be just growing old growth forests, and you're never intending on harvesting the trees. But again, it's this whole process of different treatments that you do over time. And one of the most sort of, to me, exciting and challenging parts of forestry is that it's this long-term thing, right? You're planting a forest, or you're doing a treatment that, you won't really see the effects of for 5 years, but really you won't see what that effects of the treatment are for 10 or 20 years. And, just now I did some of my first harvests in the early 2000s, and here on Vashon Island where I live, I worked with this community forest group here on the island. And just now, 15 years later or 18 years later, I go back and you can really start to see like the cool stuff that's happening out there from your treatment. And so it's, like I like to say, silviculture is, it's like gardening with these really big plants on this really long time scale. If your treatment doesn't work, you can't just pull things up and start over, right? So it requires a lot of thought, a lot of understanding of how these systems function, and because if you do screw up, things take a long time to fix. And that, as I'll mention, gets especially hard with climate change, right? Where the climate's changing, where we have to think long term, but we don't necessarily know what's going to happen. So these are our sort of traditional even age plantation silvicultural system, which is the dominant silvicultural system here in the Northwest on private land, certainly, as well as, well, the state kind of does a hybrid of the system. But basically, when you drive around private forest land in Washington, you see it all the time, right? You do these big clear cuts, and then you plant an even age, dense forest of usually Douglas fir, maybe some other species, and that grows up over time. This is actually ponderosa pine over here. Grows up over time into this, they're all the trees are the same age, relatively the same size or same height, and you have these pretty uniform stands, and they get to a particular age. You may thin them once or twice along the way, or maybe you don't thin them, and then at age, 35, 40, 80, you harvest them again and start over. And it's very much kind of an agricultural based model of forestry, and in sort of its approach and thinking, and including, one of the sort of real shifts in even age forestry over the last 10 or 15 years is the increasing use of herbicides, to where after they clear cut a stand, they spray once or even twice to kill all the competing vegetation, which is all those native shrubs and herbs and whatnot that have a lot of value for wildlife and everything, basically to kill all of that. So when they plant trees, they grow much faster and can take over the site and don't have that competition. And so for me, there's nothing wrong with managing forests to make money or to produce wood. Society needs a lot of wood. The wood's a great environmental product in a lot of ways. And I personally don't have a problem with even age management, but I think when you manage to sort of really maximize profits, and you're excluding a lot of the natural parts of the ecosystem, that does have long-term consequences that I think we're already starting to grapple with it and whatnot. So anyway, I'll move on here. So the other sort of, kind of classic silvicultural system are called even age systems. And these can be group selection systems. I'll talk about this a little bit more later. Where you essentially you cut gaps or patches in the forest, and you sort of do that over time, or it can be these individual tree selection systems, where you're growing different cohorts or ages of trees in close proximity to one another. And as you notice, all of these systems have these three phases: this forest establishment or regeneration, the tending, there's intermediate treatments, and then some kind of harvest or stand replacement. And these can be with individual tree selection. It gets all kind of blended together when you do an entry, whereas even age systems, they're very distinct phases. You go in and you plant, establish a stand, do site prep, then you thin, and then you harvest. Where in these systems, you might go in and do all three of those in different parts of a stand over time. And then there's this third type of system, which has kind of emerged really in the last 20 or 30 years, which I think is, called ecological systems. There's this book I showed Kurt, if you want to, I don't know, it's how it's been spelled, Ecological Silviculture, which just came out recently, that's really sort of, I think, the most up-to-date tome on ecological silviculture. There's retention systems, variable retention systems, that where there is a long-term wood production objective, and you're doing, these variable retention harvests, which I'll talk about, as well as planting and whatnot. And then there's also kind of restoration systems, where the goal isn't necessarily to do, long-term ongoing wood production over time. The goal is really to restore a forest, usually in this part of the world, you're trying to grow it into an old forest down here with a lot of large trees and snags and complexity or whatnot. In some cases, you might just be trying to reestablish a forest, right, in a patch of blackberry invasive species and a lot of parks. The goal is to just reestablish, restore that forest and get it growing so forest dominates the site again. But there's not really a long-term plan to thin it and harvest it kind of over time. Where am I going? Whoa. Okay. Yeah. Okay. So again, this is to me what makes silviculture so interesting and dynamic and challenging, is that there's a lot of parts to it, and you as a forester, what I love to say, one of the things I love about it is you're right in the middle of it, right? And at the end of the day, you have to make a decision about how to manage a particular piece of ground. And in forestry, you never have complete information. You never have the perfect inventory data. You never know what's going to happen down the road. There's always sort of, you don't know what logger you're going to get. You don't know what the markets are going to be like. But you have to take all that into account and make a decision and move forward. There's all the social side, which is complicated and uncertain. Whereas when I had this academic part of my career, scientists, they love to be, and I'm a scientist, we get to say, well, based on our research, this is what we think you should do, but there's all this uncertainty and we really don't know. We need to do more research. So, here's what we know, but we really don't know a lot. So, good luck. And then they get to go away and they don't have to actually make the decision. And so again, that's what I love about forestry is that you're in the hot seat, so to speak. So anyway, so when you're developing a silvicultural system or designing one for a particular landowner, and I understand you guys are going to be working on a management plan or as part of this class. And so one of the key parts of a management plan is really defining the silvicultural system for that particular piece of ground and owner, right? And so all these things go into designing that system. So the first part is just the current conditions of the forest. And there may be a variety of different forest types on that ownership with different structure and access and all kinds of things. Then you look at the basic biophysical template, the climate, the geology of the soils, the disturbance regime, the ecology of this site, which you guys have been learning a lot about, the tree species, how they grow, all the other plants, how they interact, what the disturbance regime is, and then the landscape context, which is a sort of whole nother side of forestry, where we're not just managing individual patches of forest, but we're really looking across larger landscapes and figuring out how to restore or move these whole landscapes in particular directions. But I think when you're starting in forestry and you're writing a plan, that can be a little bit overwhelming. But nevertheless, you still need to think about, what is the land surrounding me and how does that influence what I might do here? And then how does my forest contribute to the larger landscape, whether that be, in terms of riparian, aquatic function, whether that be habitat for particular species, whether that be invasive species and whatnot. None of our forests are isolated from other parts of the landscape, both ecologically and socially as well. And then there's the whole social side, which I talked about quite a bit, and particularly on public land. You just can't ignore the public, and you have to learn how to work with them and listen to people and have processes that allow for constructive feedback and engagement. There's a whole legal side to forestry. And then there's all of the economics, which is really a major, a lot of foresters, particularly if you work for industry, a lot of what you do is deal with the operational side of forestry, is, doing cruising to figure out how much value is there, setting up the harvest, doing the contracts, and then managing the logger, and then dealing with the revenue and all that stuff. And again, that stuff is really interesting and a lot of fun. If that's all you do, I found it got a little boring after a while, or I wasn't that into it. But in the context of all these other things, it's great, because if you're just doing sort of theoretical work or ecological stuff, that's all cool and I'm all for it. But when you get into the business side of things, it just makes it more interesting, or adds another component as well. And forestry is very much a kind of blue collar business like construction or whatnot. Things are always going wrong or breaking, or they don't work out quite how you think they're going to. And so again, once you kind of get used to that, it makes it fun and interesting. And then there's these other components. So again, we have all these things that go into defining both the possibility for a particular site, as well as the constraints that it has. And then you factor in the landowner objectives that has, the economic, ecological, and social, and then you figure out, what that silvicultural system is going to look like. And so I just want to kind of end this little part by saying, this traditional definition of the art of science of controlling forests on a sustainable basis. There's this idea in forestry that we know we can plant a tree today or a forest today, and we can know what's going to happen to it over the next 50 years. We have, all this science and data going back that we've developed in forestry. We have all these growth and yield models and whatnot. And it's this predictable thing, right? And you can control the vegetation to, evolve in a certain way. Well, as you guys might imagine, you bring in climate change, and also this dynamic social environment that we have, and that goes out the window, right? The reality today is that the control, predictability, stability, all those things, that's not the world we live in. We live in this very dynamic social and ecological systems. And so as a forester or a forest ecologist, you can lay out the best silvicultural system today that you think makes sense, but then recognize that you're going to have to adapt to change over time and be aware of the change and adapt to it and maintain options over time. So it adds yet one more challenge to forestry of, the world's changing all the time, and we've got to be aware of it. So, okay. So now I'm going to jump into ecological silviculture itself, and sort of get into some of the different harvest regimes and really sort of drill into that. So, when I talk about the Northwest, I'm talking about the west side of the Cascades, our wet forests, which are really primarily, Western Washington, Western Oregon. When you start to get down into Southwest Oregon and Northern California, except out on the coast, this is really more of a forest that did have a fair amount of fire. It's in some ways more similar to Eastern Washington or Eastern Oregon. It's kind of a hybrid of West-East meets. But really, the silviculture we're talking about is these Douglas fir dominated forests with Western hemlock and cedar and whatnot, as well as, if you get up into the mountains, silver fir, or get out on the coast, you can have, Sitka spruce and cedar and hemlock forests or whatnot. And so, of course, these are characterized by a lot of rain, and they're highly productive and have some of the highest levels of biomass of anywhere in the world. Some of the tallest trees in the world, I think, if not quite the tallest, but definitely some of the coolest forests on Earth are right where we are. And I've had the privilege of working with a number of different sort of forest ecologists who have really traveled all over the world and seen a lot of forests, and they all say, we have as cool a forest here in Washington and Oregon as anywhere in the world. Not to say there aren't really cool forests all over the planet, but we're really lucky here, not only in the size and the beauty and the complexity of our forests, but also in the diversity. If you go from the coast to the lowland Puget Sound to the mountains over to Eastern Washington, over to Northeast Washington, we really have this wide array of forest types with different disturbance regimes. And, one of the cool things for me has been, I started out really cutting my teeth here in Western Washington and in these forests here. But then you go start working in other forest types, and you have to kind of learn the ecology and the silviculture, and it's a whole new thing. So, there's always new challenges in forestry, which is really cool. I did some work or projects down in Georgia in the longleaf pine ecosystems, which is a whole nother world down there. So anyway, really ecological forestry, I think, kind of formally really started in a way, if you will, or you can look back to a pivotal moment, was the Northwest Forest Plan. And that's what was the major shift in management of our federal forests, national forests here in the Northwest, where we went from managing primarily for wood production to managing primarily for restoration, old growth forest, habitat for spotted owls, a whole lot of other species, as well as producing wood is part of it, but it's not the driving management goal. And the type of silviculture and treatments that are happening really changed, night and day from what was happening before. This is from 1994. And so ecological forestry really started to a large degree on federal lands and has continued on federal lands. That's not to say that there's been a lot of private landowners and small landowners and land trusts and counties and all kinds of different people have developed and have had for a long time sort of more ecologically oriented silvicultural systems, but they're a were anyway a relative minority of landowners, or certainly land acres, in Oregon and Washington, up until maybe about 20 years ago, or when these concepts really started expanding. So today we have a wide array of different kinds of landowners managing with ecological forest systems, forestry systems. So I think ecological forestry started with the Northwest Forest Plan, but you can go back to Mount St. Helens, which is where the science really started shifting. And Jerry Franklin was pivotal in this, as well as a number of other scientists. And what Mount St. Helens did is it really sort of made these scientists rethink the concept of, and I don't know, I think you guys heard Jerry's talk. I don't know, did he talk about Mount St. Helens in it? I don't want to repeat myself if he did.
Yeah, he did.
Okay, so I won't go into it too much, but really this concept of biological legacies, and that natural disturbances don't just wipe the slate clean. When clear cutting, the idea is, well, we're just mimicking a wildfire, and a wildfire burns up all the forest and leaves this bare ground, and you go plant trees, and that's what we're doing when we're clear cutting. Well, that's not reality at all. These natural disturbances leave all kinds of legacies, which makes the ongoing, the forests that come after them much more complex and diverse and whatnot. So anyway, I think the main point here is that ecological forestry in its foundation is based on natural disturbances and a really strong, deep understanding of forest ecology, and try to mimic and work with natural development processes, as well as disturbances, versus trying to control them and manage forests in a way that is sort of separate or different than the way that the systems work naturally. It doesn't mean that everything is natural about these systems. We do some things that may be different, but at least we're very aware of it. So again, our harvest types, when we do harvests, are going to be mimicking fires or windstorms or whatnot, right? We're going to leave behind these sort of messy looking harvests with these surviving islands of trees. We're going to leave not all the wood behind, because we do want to harvest some of it, but we're going to leave behind more wood. We like this shrubby diverse plant communities that come in after harvests. This is the most diverse part of stand development when you open the forest up, right? Even more diverse than the old growth stage. So go ahead. Yeah.
Okay, so I believe I read or heard that the fires also help improve the aeration properties of the soils, and compaction is a thing, like when you're coming in there for logging or whatever, so I'm just wondering, this effort looks awesome, this looks good, but is there also anything maybe you're going to get to that, but about soil health?
Yeah. I'm not going to talk a lot about soil health tonight. That's definitely a factor. You need to consider. This is a windstorm right here. So there's a lot of upturned roots and whatnot. It definitely is going to affect the soil in major ways. Fires can affect the soil, sometimes in negative, sometimes in positive ways. It sort of depends on the circumstances. That's a whole other topic. But yeah, soil is understanding what soil you have, its properties, its productivity, and then also how to make sure you don't damage the soil. A lot of more modern harvest systems are designed to, sometimes they disturb the soil a fair amount, but not compact it. Some soils are quite resistant to compaction. Other soils are very fragile or very prone to compaction. And so you kind of have to understand those dynamics. But so anyway, you have these natural disturbances here, right? And then you have these contrasts of wood production silviculture, where you do these clear cuts, where you really remove everything. And as I mentioned here, these were site prepped. Now we're not burning as much, but we're using herbicides to really sort of wipe this plate clean, and then plant these plantations that come in after them. We also have a lot of smaller disturbances. more patch disturbances or killing small groups or individual trees. This is a root rot here. These are windstorms punching holes in the forest. This is insect mortality, creating this mosaic across the forest. This is a fire that underburned, and again, didn't kill all the trees, but created kind of a patchy forest, stimulated a lot of understory plant development here. Versus plantation, again, in this mid stage, they tend to be very uniform right here, right? Whereas a natural forest that grows up, with all those legacies from the past disturbance, and then also with those natural disturbances like windstorms or insect and disease or whatnot that mix the forest up and create a lot of diversity, you end up with forests that look more like this over here, where you have, gaps with lots of shrubs in them. You have down wood on the ground. You have some dense areas, and much less uniform than a plantation, where really, this is the least diverse stage of forestry. And a lot of people think, oh, this is really natural. I have all these trees here. It's great. But really, all these trees here, and they're all one species of Douglas fir, they're taking up all of the growing space, all of the room, and there's not much left for other plants right there. And so, it took me a while to kind of get used to the idea of, hey, when parts of the overstory blows down or dies in a windstorm or gets harvested, particularly in this part of the world, you get this explosion of life and diverse plant diversity. It's just really cool when you open up the canopy. It's just part of the way these forests function, and we tend to think, oh, we just want to focus on growing big trees, and that's the main thing we need in forests. Well, that's not the case at all. Sure, we need big conifer trees. They're really the backbone and the anchor of our forest, but all these other components are really critical as well to the function of the forest. Again, these are kind of the principles of forestry. I think Jerry went over those, so I won't really get into them in very much depth, but using natural disturbances as a guide, we're really working with natural disturbances and then maintaining these legacies through time, and then this multi-scale approach too. And as I've talked about, really managing for multiple objectives, which is what makes it harder and also more interesting. So I kind of went through this already as well a little bit in terms of, but when we get into ecological forestry, we have these same phases where we have an initial, we'll start at the other end, kind of, you have a forest and you do what's called the variable retention harvest, which I showed you some pictures. And in that, after that, you're going to do plant or use natural regeneration to establish a new stand. And then you're going to do some tending over time, which might be controlling vegetation. Some use of herbicides sometimes can be necessary, and I think is okay to make sure your trees actually grow. I've spent years on my land trying to get conifers to grow up in the shrubs that, our shrubs grow so fast here, it's hard to get trees to grow. As well as early thinning, pre-commercial thinning or non-commercial thin, and then doing this variable density thinning, which is kind of that intermediate treatment in the life of a forest, which is, often when you have a young or mid-age dense forest, we can do this variable density thinning, which I'll talk about, right? And as I talked about in a restoration kind of system, you may never do a variable retention harvest. You may do these kind of things to move it towards old growth harvest. Let's see, I had some pictures here. So again, the uneven age systems, I talked a little bit about that. Here we go. So one thing that happens a lot in forestry is, we have these three different systems. They have these different components. Again, the sort of big difference when uneven age system is everything is happening at once in the forest. You have multiple age classes, and you're doing different treatments at different times. Ecological forestry is somewhat like that as well. When you do a variable retention harvest, I'll show, you're leaving behind a lot of trees that become part of the next forest. And when you're thinning, you're creating gaps and you're removing some overstory trees. And so you're going to develop multiple age classes, right? And so it's it's not as linear. This is a very linear system. This is a very sort of circular system, and this is kind of somewhere in between. But the reality is when you get out on the ground, a lot of these individual treatments can look very similar between these different systems, and people can get very confused about what different things are called. And in silvicultural terminology, people can get sort of the professors of silviculture, they're very specific about their terminology, and they want certain types of harvest to be called certain things. But in reality, it's a little bit of a mess out there. People are using all kinds of different terms for different kinds of forestry. But this is the way I think about it in terms of ecological forestry, this variable retention, regeneration, and then these early thinning treatments or tending, and then variable density thinning are sort of the main things that you might be doing. And by veg control, that could also be invasive species control as well. So again, again, that key thing that we're maintaining biological legacies and components throughout this whole system. We never kind of wipe the plates clean here. I'll say too that within an ecological forest system, you can use some individual tree selection or group selection approaches, is kind of what I was talking about. These things tend to cross over and get a little messy. And so like a variable density thin in many ways is it's an individual tree selection harvest with some groups or patches that you're putting in there. And so a traditional silviculturist might come and say, oh, you're doing an individual tree selection, with groups or patches. And I say, well, no, I'm doing a variable density thin. And, it's kind of the same thing, at least on the ground. So this is a lot of just where these concepts were developed and who's calling what. So when we talk about those key biological elements that we want to manage for and maintain in these stands through time, these large trees with complex crowns, a multi-layered canopy, or dead wood, so snags, lives, and also live trees that have rot and cavities and whatnot in them, really high habitat value. A diverse plant community, both in the understory, but as well as broadleaf species, our maples, alders, madrones, willow, all those are not always great in terms of value. I mean, alder can be worth a fair amount, but really important for biodiversity and also for resilience to climate change and disturbances. To have a broadleaf component definitely helps your forest out a lot. And then this idea of variability or patchiness in a forest. We're not managing for those uniform conditions, but more for patchy kind of conditions. And then also there's these other biological elements, the soil, and all of the organisms living in the soil, fungi being a major one, as well as all the invertebrates. And then of course, vertebrates as well, whether those be deer and elk that are really influencing the forest by eating vegetation, eating your trees, making an effort to grow, whether it's birds and small mammals that are dispersing seeds in the forest or different species. Those things are definitely out there and a key part of the function. They're just harder to see and to manage for, right? We can't say, I'm gonna make sure there's certain species of fungi over here, whereas we can say, I'm gonna manage for a large tree right here, and we can see it and measure it and monitor it over time. So one of the other things I love about forestry as opposed to wildlife biology, that trees don't move. You can measure them, you can go back, and they're much easier to measure and monitor and sort of understand over time. So I think, did Jerry talk about sort of forest development in the Northwest? I think I'm not really going to go into this here, but in any length anyway. But the basic idea here that there's these different stages of stand development in a natural forest. The first one being, we have a disturbance event, which is usually a large wildfire like we just had in Western Oregon. Those were really devastating fires for communities in Western Oregon, but ecologically, they were actually sort of natural fires that are part of these systems where we have these east winds and these really big, huge fires that really, look like that over thousands of acres. And I just saw some fire severity maps from the fires in Oregon, and there's, big patches of forest that look like this. Not all the trees died. There's definitely some seed source trees in there and patches and whatnot that survived. But anyway, you have these big disturbance events. It creates all these legacies, all this dead wood. There's also a lot of plants, non-trees that survive through these. And then in this stage, you have this crazy colonization. And as I mentioned, really high biodiversity, both trees and all kinds of other plants, lots of insects that feed off the plants or whatnot. And then eventually, depending on the system, how fast this happens, trees establish and they grow up enough to take over the site and to shade out all that vegetation, other kinds of vegetation. It's called canopy closure, and the forest really starts to put on biomass. You have really fast height growth and stem growth, and there's a lot of competition that starts to come in here. And so this is where the trees that grow faster tend to outcompete the smaller ones, and they end up dying over time through competitive mortality. As my silviculture professor liked to say, this stage of forestry, the rich get richer and the poor die, which is sort of unfortunate, but true to some degree, although it's more complicated than that too as well. And so then you go into a little bit later stage of this young forest where now the trees are getting bigger. There's been some mortality here, like this snag that died from again, it's just really like in a garden when you have too many plants packed together, some of them are going to die and kind of sort themselves out. Do note that what I'm talking about here is a little bit of a caricature of stand development. It tends to be messier and more complicated in real life, but this at least kind of gives us an idea. And then we move into the mature forest phase, where now the trees are slowing down a little bit in growth. They're still growing pretty well, but we start to get other vegetation coming in, understory trees and whatnot. The canopy starting to open up from wind or root rot or whatnot. And then the last stage is old growth, where we really have these big old trees that dominate the forest. We have vertical canopy layers, lots of hemlock, cedar, shade tolerance growing up. We have a lot of gaps and complexity, and a lot of dead wood as well. And of course, these are as I mentioned, have some of the highest levels of biomass or carbon of anywhere in the world. So, they store a huge amount of carbon in these forests. So again, these are just pictures of old trees. So I guess what's important to recognize, as I said before, it's never quite this simple. This is an 80-year-old hemlock stand that looks like a 50-year-old or even 30-year-old Douglas fir stand, just because it grew up so dense and there's nothing growing on the understory. Whereas this is a 45-year-old kind of mixed stand that grew up with more disturbances in it. So it's kind of a lot more complicated, right? And more diverse or whatnot. And so why I went through that is, again, when we're doing ecological forestry, we want to understand not just natural disturbances, but also these natural development processes and how they work, because we're trying to mimic those and sort of work with those and when we're designing treatments. So I'm going to go through now the steps in developing a variable density thinning prescription, because typically with ecological forestry, this is one of the main treatments we do, because we have all of these plantations that got established during the era of production forestry. Again, this started on national forests where up until the mid 90s, they were creating all these plantations. And then they decided, whoa, now we need to manage for old growth, for more diversity, and shift over to ecological forestry. What do we do with all these dense plantations? And so that's where variable density thinning emerged as a way to make them more diverse and to try to develop those old growth or mature forest characteristics more quickly than if you just let them alone. And similarly, King County or Nisqually Land Trust, a lot of kind of conservation owners will buy industrial forest land or individual landowners maybe buy a patch of industrial forest land, or buy a forest that is a plantation, and they decide, hey, I wanna create a more diverse, complex forest, better habitat. Hey, I'd also like to make some money, produce some wood, and that's where variable density thinning is a great treatment. So in a lot of cases that's where we're starting. So the first step in developing a thinning prescription is to really clarify, and this goes with developing a management plan as well, really clarify your management objectives and your constraints. If you remember in the beginning, there's all those different components of forestry, spending some time to really get clear on, what are your goals? What are those social factors and economic factors and whatnot? What is your public response? I don't know if Kirk's told you or whatnot, but one of the, I'm trying to remember his name now. My brain's not working. One of the guys in one of those photos was, I haven't seen him for, what was his name? He was a professor of silviculture. I don't know, Dylan, if you're there, you remember him. He was a professor of forest ecology or whatnot at Evergreen. I don't know, maybe 20 years ago or 25 years ago. I met him when he worked at Fort Lewis for a while. And he, with a group of students, developed a plan to do a variable density thinning prescription in the Evergreen School Forest. And I don't know all the details of it, but it became hugely controversial, and he got kind of run out of Evergreen. Again, I don't know if that's totally true. I don't want to spread rumors, but the point I'm trying to make is that if you don't really make yourself aware of kind of the social context and objectives of what you're doing in, you can end up getting into trouble pretty fast. Kirk or anyone, if you remember his name, let me know, because my brain's not working. I'll think of it in a minute. Anyway,
I'll tell you offline.
I think
okay.
Gabe Tucker, Derek.
Thank you very much, Gabe.
Yeah.
Okay,
Yeah.
He's a great guy. Anyway, so so the next phase is to assess those stand conditions, and I know talk to you guys about that, going out and putting in plots and just walking the forest to really get a sense of what's out there, the composition and the structure, but also the history of the forest, how it got to be there, when was it harvested, what kind of disturbances are there, was it planted, did it regenerate naturally, and then what is the disturbance regime of this site. And even though in Western Washington, our main disturbances are fire and then wind and insect and disease, different parts of Puget Sound, there's different flavors of our forest. There's drier sites. In some cases, root rot is a really big deal. In other cases, wind is a really big deal. And so, you need to know what are those real disturbance drivers in that particular site, so that you can incorporate them into your thinking. And then looking at, topography in this part as well. Soils are a major issue, understanding the soils. And then those operational considerations. Do you have road access? What kind of logging systems? That kind of stuff. Again, though, getting that landscape context there. I'll go through that. And then the main step here is defining these main parts of the prescription. And so the first one I always like to say in a thinning prescription are, what are your biodiversity hotspots? Are there legacy old growth trees in there, large snags or pockets of hardwoods, pockets of dead, large dead wood, really tall vine maple, things that are really unique and ecologically valuable. So identifying those and then deciding, am I gonna protect those or not, put a flagging around them and not do any treatment around them, or am I actually going to release them? So if it's like madrone trees where I live, a lot of times, madrone has great biodiversity value, habitat value, and so we'll release the healthy madrones. We'll cut the Douglas fir around them, or with maple sometimes, because we want to promote that hardwood component, and it's being overtopped by Douglas fir. And most of our forests, we have lots of Douglas fir trees, as I said. We got plenty of Douglas fir. So sometimes removing even some of the larger Douglas fir trees to release those other elements can really be cool and important. And then you want to look at, okay, what do I need to add potentially? Do I need more dead wood? do I want to, if I'm going to do a harvest, do I want to leave a component of that behind for soil health and all the habitat value of dead wood, either snags or logs? Or in some cases, people don't harvest the trees at all. That Cedar River watershed and some other places, and you could choose to do that at Evergreen. I don't know. And, you could leave the wood, on the forest floor. I've worked with some landowners who more mimicked windstorms, where every 4 or 5 years, they would go in and they would cut little patches and they'd cut trees down to just diversify the forest, kind of mimic those natural disturbances. But they just leave all the wood on the ground. They weren't really interested in harvesting. And it actually worked really well for their objectives, right? Again, that it all depends on your context and whatnot. And then also, are there trees or shrubs or other plants that you want to introduce to that site? Sometimes in plantations, we only have one tree species. If the understory has been sprayed with herbicides a bunch of times, we may not have the plant diversity that we want. And so you want to reintroduce some of those species and plant. And then the third, and at this point, you're just defining, what you need. And then later on, you'll decide when in the sequence you're going to do it. And so the next step here is, okay, what are you going to leave and remove in terms of the trees? So we call that the thinning pool. What species are you going to select for to remove or leave? What size classes? Are you going to take just the smallest trees? Are you going to take intermediate trees? Are you going to take some larger trees for different purposes? And then the overall number of trees that you're going to leave behind, your density target. And that's really probably the most quantitative and sort of scientific part, if you will, of thinning is defining how many trees you want to leave behind. And I don't really have time to go into the sort of math and nuts and bolts of that today, but certainly could at some point, or Kurt can. But getting that density target. And then the fourth part is that heterogeneity of are you going to create gaps? Are you going to leave skips behind? Are you going to thin some areas heavier than others to create that kind of variability in the stand? So putting this all together, you're going to go out and look at our biodiversity hotspots that I mentioned right here, that you may or may not have what to add, deadwood or snags. Here, planting, we might leave dead wood. This over here on the left is a heavy thin, down to about 50 trees per acre, really opening up the forest. It's a little shocking at first, but these trees you leave are really going to grow fast, and you're also going to get a lot of response in the understory. This is a more moderate thin, leaves but trying more trees, and they both have kind of advantages and disadvantages. And then this is this heterogeneity piece, where we're not leaving behind that uniform canopy. And so when we're doing that, I like to think, again, there's these four basic or three different patch types, or four different patch types. We can leave behind skips where we don't thin at all. We can do heavy thins. We can do openings, gaps, maybe leave a few trees in those gaps. And then we have this sort of general thin where we're just kind of doing our general prescription. And so, this is a schematic of a treatment I did with the Forest Service where we have these big root rot treatments were kind of like openings here. These were sort of small clumps or skips that we left here. These are bigger skips that we left. This is a riparian buffer, which is kind of like a big skip. And so all these little elements really break up the thinning and again, are mimicking that natural disturbance. And then the last part of this is just, thinking about this fine scale we see in forests of clumps and gaps. When you go into a natural forest, it's not evenly spaced out. You have 3 or 4 or 5, big trees kind of in a grove over here. You have a little opening over here. And that's important for both habitat for different critters. And we actually are learning that these trees and clumps, all their roots are grafted together, and they're growing more like one big tree where they're sharing carbon and resources and water across those root networks. And they're actually, the roots are often linked through mycorrhizal networks. And so, you know, the idea that trees are always competing is a little bit simplistic. Yes, there is definitely competition for light and whatnot, sometimes water between trees, but there's also this sort of cooperation among these groups of trees as well. Anyway, just making sure that you leave behind some clumps and create kind of this finer scale variability, because in general, traditional forestry, people are sort of used to kind of spacing a stand out. And when you do that, you tend to get sort of this uniform light environment, which can lead to sort of a uniform shrub response, versus when you create a more variable situation, like over here on the right, have different kinds of growing in parts of the forest, different critters will use like this dense area for some things, and they'll forage in the patches. So you have higher biodiversity when you have more of these patch types, right? When you have a forest like this. And this forest, incidentally, is from Fort Lewis. It's had 3 different variable density thinning entries where they've gone in and taken out wood and created really this very variable forest with a lot of diversity and whatnot. So so I'm just going to end here by showing this other piece of the so that's kind of the thinning prescription that we're going for. And then the other sort of major treatment type in ecological forestry is, in terms of harvest, is variable retention. And, some of these pictures are kind of sort of shocking in a way, or it's just this harsh like thing when you do a harvest. But these are very different ecologically than a full clear cut, right? You're leaving behind these clumps of trees, aggregates of trees, very similar to those huge fires that just burned through Oregon. If you look at those, they have a lot of this kind of retention right here. You can also do what's called dispersed retention. Again, these are just pictures of aggregated, where you have different patches. Here's another version of that. Here you have these patches, but you're also leaving individual trees out there. That's called dispersed retention. Okay, that's more of that more uniform aggregated retention. So anyway, again, the goal here is to harvest most of the trees for wood production, start a new stand, but again, leaving behind, similar to the way a disturbance does, some of those big old trees for the next forest. So I'll stop here, and we have some time for questions or comments or whatnot. So.
Yeah, great. Thanks, Derek. Yeah, let's open it up to the class. We've got about 20 minutes or so for some Q&A. While we've got Derek as a resource, folks have some questions about his presentation or comments, observations.
Hey, Derek, how are you?
Doing well. How are you? Yeah.
Awesome. I just have some questions. It was a great presentation, a lot of great information. I was just curious, as a person working in the industry, how do you feel about the advent of systems like AI systems that would, take a lot of the legwork out of this type of management and help give prescriptions that are, faster, more accurate than what somebody, you could just feed all this information into the computer? And how do you feel that's going to affect forestry moving forward?
Yeah, that's a great question. First of all, I will say that forestry is not a particularly sort of dynamic profession in terms of adopting new technology and new practices, which can be a little bit frustrating, to be perfectly honest. The private side of forestry tends to be a little faster. Public forestry, particularly like the Forest Service or whatnot, it's just really hard to get them to adopt not just new forestry systems, but like new ways of using tablets or other technologies that can really speed things up. That said, technological change is happening for sure, but we're not like the tech industry, which is constantly innovating and all that kind of stuff. That said, if you are an innovator in forestry, you have a lot of room to roam, because, as I said, it's not like it's not a sort of super fast moving profession. However, there have been a lot of recent advancements. LiDAR is probably one of the biggest ones. I don't know if you're familiar with that, where you fly over the forest with a laser and you get these super accurate maps of both the ground, which that's the sort of main use of LiDAR, at least for most people. But then you also get these incredibly accurate maps of the forest canopy. I've done a lot of work with LiDAR, and it's really amazing stuff. And for mapping and understanding forest structure, and you can get it on a tablet or on your phone and go out in the field with your little GPS and see where you are and see the trees around you. And so it dramatically speeds up or makes your recon time in the field much more efficient, because now you have this three-dimensional overhead view of the forest, both with an aerial photograph like Google Earth or whatnot. You can walk around, or Google Maps, and you can see an overhead photograph of where you are, but also this LiDAR imagery. And so you can say, oh, there's a really big tree over there, there's a gap over here, there's a thing, and that can help you understand the forest better, and also develop better prescriptions and whatnot. And when you scale that up to developing management plans or prescriptions for the Forest Service or large acreages like what I do, that technology is super important to just having better data, current conditions data, which is really improving our understanding of these forests, how they're changing over time, and how to manage them. And that kind of technology is only sort of getting better and cheaper over time. There's other versions of it with stereo imagery where they can get kind of LiDAR-like products. And then, of course, taking all that into the field, there is a lot of advancement in harvesting technology. As I said, that side of forestry is more innovative, and to where they put a lot of it. Used to be, there'd be 4, 5, 6 guys out on a cutting crew. Now there's often just 1 or 2 guys in a machine, and they can produce a lot more wood per day than those 8 people did. The same thing in industry. But in terms of the work that I do, there's so many different components, as I've talked about, to forestry that you just can't replace that with a machine. And so, we've done some automated prescriptions with LiDAR. I've worked on some stuff like that, and it helps. It gets you part of the way there, but technology is just not going to understand all the different ecological sides and all that, not to mention the social sides and all of that. So I really don't see this technology replacing people very much. I think it just sort of enhances what we can do, and makes us much more efficient, or sort of more effective and better at it, rather than sort of replacing people. That said, like all industries, if fewer people can do more, there probably are less jobs overall. But it's not dramatic for sure. So.
Great, thanks. I was just thinking about the integration of technology with just these large land masses, and how it could just it's more a tool, I guess. Yeah, but
yeah, and there's a lot of work in that. It started with Landsat satellite imagery, was sort of the first version of it, and there's a lot of constant and remote sensing, getting better large scale information. So there's still a long way to go in that, but we are getting better all the time. We're sure the Pentagon has really good information over, amazing LiDAR or satellite imagery and stuff that we don't have access to. But yeah, and I don't know, Kirk, if you guys are interested or whatnot. There's LiDAR for pretty much all of Washington now, and I'm sure there's LiDAR for the forest if you guys want. And do you have that? Do you have the?
Yeah, I do, through NNRG. We're not really getting into that in this class. It's a little bit beyond the scope of the elective.
I was just gonna say, if you guys want to, on like Avenza maps or whatnot, I'd be willing to do it, or Dylan or someone who has GIS could just produce the Avenza maps, and then when you're out in the field doing recon, you can just have it on your phone and have a little dot and be like, okay, here I am. And just using like that can be pretty cool.
Yeah, well, I'd love anything you've got, Derek. I think our last LiDAR coverage for tree heights on campus is maybe 2008 or something like that. So it's getting a
Yeah, we have this DAP stuff, which is from the NAPE imagery. I won't get into it here, but
yeah.
do you have ARC? I mean, are you
Yep.
a GIS personnel?
Yep.
Yeah, I can just send you some stuff, and if you're up for it, it's pretty fast to work some stuff up. So
Oh, that'd be great. I'll put my email in this chat.
yeah. So great question. Yeah,
Other questions for Derek?
Derek, I've been hearing more and more about the role that conservation and land trusts have been playing in acquiring more land, taking it from taking it mostly from private and what appear to be mostly harvest and industrial forests. Do you believe that is this like a recent trend? And do you think that this will be playing a meaningful impact on um, the extent to which that northwestern forests can reform in advance of climate change? Or do you believe it's just kind of a nothing burger and it's just not really going to leave much of an impact?
kind of on the margins. I mean, if you look at the land ownership, by acres, in Western Washington, industrial forest landowners, they own the most productive forests, low elevation, most productive forests. Most of that is in Southwest Washington, both, east and west of I-5, and then around the Olympics, and then up in around Everett and sort of north of Seattle and whatnot. Big industrial holdings. So I think industries really sort of tended to consolidate where, into the most productive areas. And in those areas, I think, at least right now, industry is really hanging on to those lands because they can make money and do well. But lands that are closer to big cities, that are less productive, where you can make more money by selling, converting them to real estate or to homes or develop them. Those are the places where you see a lot of activity of conservation organizations and counties, sort of NGO, where we're trying to keep these lands from converting, and going to these other ownerships that are going to manage them. So I think, while if you look at the net number of acres across the state on private lands, industry is still really big, and a lot of small private landowners manage for revenue or whatnot, for a variety of means. But in particular locations, again, places where development pressure is really high, conservation organizations, I think, are having a big impact. And if you look at the sort of carbon aspects, the biggest role that our forests play in climate change is both sequestering and storing carbon. We have a huge potential here. And so, the biggest difference in carbon is whether you develop it or keep it in forest, right? That's a huge fork in the road for carbon. So even if you're managing it fairly intensively, that's a whole lot better than letting it be developed, right? So there's been a lot of people that are doing the working forest easements, where they don't necessarily buy the land and change the ownership, but the forest industrial owner sells the right to convert that land to development. And so it's kept in forest management in perpetuity. And they get paid for that, right? Because they're giving up something. So conservation organizations will buy those development rights. But then that landowner can keep managing the forest however they're, according to their management plan. So that's kind of another sort of intermediate tool there and that both here in the Northwest and all over the country is a big deal. There's a lot of acres under those working forest easements. So yeah, I think it is having an impact. Is it, are we taking over the world or whatnot? No, but again, there's a role for all landowners on our landscape. We definitely need industrial forests, both for the wood production. They also sustain the milling infrastructure to a large degree. So, they're important for that role.
Thank you.
Other questions?
Derek, this is Paul Butler.
Hey there.
I'm a emeritus faculty and kind of new to forestry. My background is in earth science, and I gave an introductory lecture a few weeks ago. But
Cool.
two things. I'm working with Capital Land Trust to donate my forest when I won't be around anymore. And one of the things that attracted me to them is that their desire to have working forests and working agricultural systems, near urban areas. And so in the watershed where I am, my forest is in the headwaters, and then they have another large tract of land lower down around Lake Lucinda. So it's one of the things that attracted me. But my actual question is, in writing your management plans now, are you doing anything in your plans thinking about climate change, especially the drier summers?
Yeah, that's a good question too. Yeah, I didn't really talk about that obviously, and sort of talking about more of the kind of foundational parts of ecological forestry. And of course, a big part of what we're managing for these days is sort of resilience or adaptation. And Kirk and NNRG just organized a series of workshops on exactly that topic. How our management regimes and approaches are sort of evolving or shifting because of climate change. And Kirk, I don't know if you're going to bring any or talk about that at all in the course, but it's it's definitely something we have to consider. Currently in Western Washington, with the climate projections, I don't think there's a need for sort of radical change at this point. We don't need to start planting ponderosa pine or trees from California or whatnot here. The future climate looks like in most places we're still going to be able to grow Douglas fir, as well as most of our other species. Their ranges might shift around a little bit. So, on your drier sites in low Puget Sound, you might not be able to grow hemlock. It might not survive in the near medium term future, or some of those less drought tolerant species might not do well, but they'll actually do better at higher elevation, right? So they might shift a little bit, or will shift to some extent. It could be also that today's trees out there that grew up in a wetter, cooler period may not do very well in a drier period, but Douglas fir, has a really wide genetic amplitude, and a Douglas fir that's adapted to a climate can still grow here. So it is really important to understand what the projections suggest for your particular site, where you live, what it looks like, what your forest is like, what species it has, what your soils are like. That makes a huge difference. If you have droughty, super well-drained soils, or if you have soils that hold more water, that makes a big difference. And then you can really think through, okay, how are warmer and drier summers really going to affect this particular site? Because there's not one answer for everywhere, right? And a lot of people say we don't need dramatic change, but we do need to be aware of it and probably manage our forests more proactively than we have before. So.
Yeah, Paul, as Derek mentioned, NNRG is part of this climate adaptation strategy effort. We put together a white paper that looks at climate projections, impacts to forests, and then lays out a range of forest management strategies to make forests more resilient. And then we created a companion document that is a kind of a guidebook for forest management plans and how to incorporate these ideas into plans in a prescriptive fashion. And I'll send both of those to you. Our class just in the past week and a half read through both of those, and that's part of what we'll be incorporating into the management plan for Evergreen that they're developing. But I'll send those out to you to take a look at. Got a few more minutes. Any other questions?
Yes. Hey, send them to me, Kirk, too. I haven't seen the final versions of those, so.
Oh, sorry about that.
I'd love to see them.
I guess I have more like a mentoring question than an academic question, in the
Sure.
sense that like this course is about ecological forestry, right? And Kirk has really challenged us to think about what that word ecological means. He shared a little bit about his life, how he used to go protest cutting of trees, and how his perspective has changed over time. And I think something I struggle with personally is like, I would really love to contribute to the forest in a way, but I'm so scared of harming it more, just based on
Mhm.
patterns. Like usually human interactions have done more harm than if we would have just left it alone, I feel. So like
Mhm.
what, and I'm not trying to challenge you, it's really a mentoring
Oh,
question.
no,
What
it's a
gives
great
you the
question.
confidence to like do this
Yeah.
work and know that you're looking out for all biodiversity and not just the human species? Like, how do you navigate that as your career develops?
Yeah, I mean, I think that, for me, it started with, I spent a lot of time outside in the wilderness in different places when I led outward bound courses, and I started really seeing these fires or natural disturbances, and we start seeing in nature these forests are really dynamic and they're changing all the time. And when trees die, there's all this new life that comes in, and all this critters and this whole food chain that's built on those dead trees and whatnot, or on the shrubs and other plants that comes in. And so for me, it started with this real sort of passion for forest ecology and understanding these systems, and realizing that forests, again, they're dynamic. There's these cycles going all the time, and that when we cut trees down or we disturb sites, when we drive machines around in the forest, yeah, it's kind of scary. And it's like, the holy crap, when I started doing this, with small landowners, we do a harvest, and the landowners would come out and sort of the blood would drain out of their face, and there'd be like, what just happened to my forest, and because all the understory was trampled or whatnot, and you're like, and I sort of learned, okay, well, let's go over to a forest stand that was thinned in the same way 3 years ago or 2 years ago, and all of that understory grew back. In fact, now it's more diverse and more interesting, and so even though it looks terrible, you know from experience that the systems, they're sort of adapted to change like that. You go look at those pictures of a windstorm or a fire, and it's a similar level of kind of devastation, if you will, but because it's a natural disturbance, we tend to think, oh, this is natural, it's sort of okay. When it's a human disturbance like logging, we think, oh, this is terrible, humans messed up the forest, right? And sometimes we do mess up the forest, right? But when we understand the system and really take time to do that, I think we can really minimize those negative impacts, and make sure that as we're changing the forest, we're working with all those sort of mechanisms so that it responds and recovers, and even becomes more diverse or interesting over time. So for me, that's been Andy Carey, who is one of the main ecologists that developed variable density thinning, is a wildlife biologist. He used to say, we have an epidemic of Douglas fir in Western Washington. There's Douglas fir trees everywhere, and it's like, who eats Douglas fir? Like, have you ever tried to eat a Douglas fir needle or Douglas fir wood? Like, there's not that many species that can live off Douglas fir. There's all those other plants out there, part of the system, that provide the food webs and the array of life that we need. And so removing some of that Douglas fir, managing the forest is okay. It's a good thing, and again, that epidemic of Douglas fir is largely because of past management. And so the other thing I would say is, a lot of what we're doing in ecological forestry is trying to correct, if you will, it's a bit of a judgmental word, but sort of shift some of the patterns that were set up by wood production forestry. And again, that's not a critique necessarily of the foresters and the people who did that. You talk to a lot of people and they're like, well, I was given a particular set of objectives to manage this forest for wood production or whatnot. This was the knowledge at the time, and hey, I had really good intentions, and this is what I did, but now times have changed or whatnot. So I try to stay away from judging people and good, bad type of stuff as much as I can. But again, I think once you really understand these forests as dynamic systems, and that, you know, people have always been part of them, whether it's Native Americans, you know, burning prairies, you know, people have been involved in nature forever. And so this idea that we're somehow separate and what we do is always bad, I think, you know, it's one of the parts that I love about it. You realize, particularly when you do harvest, or planting or whatever, and then you see the results 5 years later or 10 years later, and you're like, wow, this is really cool. You know, it really shifts your thinking and gives you confidence to make those decisions. So hope that helps.
Great question.
I definitely went through a lot of those sort of process and emotions at different sort of, I'd say emotions, just sort of, you know, headspace, if you will, over time. So yeah.
Well, we just slipped past 9 o'clock. I mean, while we have Derek as a resource, if anybody has one last burning question for him, I'd like to make some time for that.
Go ahead. Yeah.
Yeah, Patrick.
I was listening to a radio discussion, and they were talking about how mills have been shifting over to processing smaller logs. I'm not sure how true this is. And so I was just wondering how that maybe is changing any kind of ecological silviculture practices. Like, you know, if the trees get too big, they're no longer economical. So I don't know how that changes your timelines or not.
Yeah. I mean, I think that the ability, having markets for smaller logs is great when you want to do early thinning projects or even sort of mid-age thinning projects, because you know, you can make money or pay for a lot of those. Even if you don't make money, at least you're not spending money for a lot of those are kind of earlier treatments or whatnot. And particularly over like in Eastern Washington or places where we have a real fire risk and there's just too many trees in the forest for that system. But a lot of those trees are small. Having those mills like Vaughan Brothers over in the Colville country is just a godsend, because you know, you have a market for all these small trees that you really want to move. And what you want to keep is the larger trees, right? And if you only have mills that take bigger logs, then you're kind of forced to harvest some of the bigger trees that you don't want to, right? So in that sense, those markets are great. However, if we're really doing longer term, long rotation ecological forestry, where instead of growing trees for 30 or 40 years, we're growing trees for 80 years or 100 years or 120 years. And, you know, that's better for habitat and for ecological functions. It's much better for carbon to grow trees for longer and not, you know, cut them when they're, you know, a 40-year-old Douglas fir tree is still kind of a teenager, right? Like it's got so much growth to do. So, however, so if you don't have markets for those large trees, it makes that kind of longer term forestry much harder. So in that sense, it's a risk. However, I firmly believe that, and just know that if there's enough volume of larger trees out there, mills will take that wood because, you know, for a long time people are like, oh, you know, we can only take a 26-inch log or whatever it was, and then a couple of years later, I was talking to this guy. He's like, oh yeah, no, we're taking like 34-inch trees now, or 36-inch trees, you know, and I said, well, did you have to get a whole new mill? And he's like, no, we just changed the debarker, changed one little thing. And it's because there was a bunch of timber sales with larger trees that they bought, and they realized, hey, you know, because those large trees they're more economical to handle, and they have higher quality wood, and you can make more products from them. So I think over time there's going to be markets for those if there's enough of it out there and enough supply to warrant whatever, you know, shifts in the milling infrastructure you need. So, you know, we'll see what happens. People have been saying that forever, that you're not going to be able to sell large trees, but you can still sell pretty large trees now. I mean, you can't sell 5-6 foot diameter old growth, but we don't want to be cutting that stuff anyway, right? You know, if it's 100-year-old 3-foot diameter tree, you can sell that no problem right now. And, you know, you may have to go to a little bit different mill, but you know, those markets exist, and I think they'll continue to exist. Could be wrong, but.
Okay, great. Well, I think we're gonna have to leave it there. And thank you, Derek, for joining us. Virtual applause. And,
yeah.
If you wouldn't mind sending me your presentation afterwards, I'd like to get that up
Sure.
on the website.
Yeah. And also, if any of you guys are interested in learning more about the DNR, the DNR it's a really great place to sort of cut your teeth in forestry to get a sort of DNR field forester position. There's also a lot of other kinds of jobs in the agency. We hire a lot of people kind of early on in their career. It's a very kind of can-do, dynamic place. It's not some sort of stagnant bureaucracy. I've had a number of different students get DNR jobs, and they learn a ton and whatnot. So if anyone's interested in more about that, I'm happy to talk to you about that, or introduce you to folks or whatnot. And yeah, Dylan, I think you have my email, but if you just get in touch with me about that, we can chat about the LiDAR thing and kind of work that up. So yeah.
Okay. All right.
Cool.